Behind the thick dust of our galaxy's plane, something colossal was hiding. It's been pulling on our galaxy for millions of years, and only now can we finally see it. In March 2026, an international team announced the discovery of the Vela-Banzi Supercluster, a structure so vast it rivals the largest cosmic assemblies ever found. Led by Emeritus Professor Renée Kraan-Korteweg at the University of Cape Town, with collaborators from France, Australia, and Italy, the team had spent years listening to radio waves that others couldn't detect. The structure they revealed stretches 300 million light-years across. It contains at least 20 galaxy clusters. The total mass reaches around 30 quadrillion suns, that's 30 million billion suns. To put that in perspective, it rivals or exceeds the Shapley Supercluster, long considered the universe's heavyweight champion, and even Laniakea, the supercluster containing our own Milky Way. For centuries, there's been a problem at the heart of the night sky. When astronomers look toward the dense region of stars and dust that makes up the Milky Way's plane, that brilliant band running across the heavens, visible light simply stops. The dust particles scatter and absorb photons. It's like peering through a thick fog. Astronomers call this region the Zone of Avoidance. Entire sectors of space become invisible to optical telescopes. Radio waves, however, carry a crucial advantage. The particular wavelength of 21 centimeters passes straight through dust as if it weren't there. Hydrogen atoms scattered throughout space emit this specific frequency naturally. They don't need a light source. They broadcast their own signal, a cosmic beacon that travels unimpeded through the dust that blinds every conventional telescope. Kraan-Korteweg first suspected something enormous was lurking in the Zone of Avoidance more than a decade ago. Other research teams had noticed peculiar gravitational anomalies. Galaxies were moving in ways that standard models couldn't explain. The universe's large-scale motion patterns, what cosmologists call the cosmic flow, suggested the presence of massive structures that hadn't yet been directly observed. It was like watching a crowd of people part and flow around an invisible giant. You couldn't see the giant, but the motion of everyone around it told an unmistakable story. Gravity was at work, pulling, shaping, organizing. To confirm the theory, Kraan-Korteweg needed to penetrate the dust. She needed a tool precise enough to map the gravity and location of these hidden structures. That tool arrived in the form of MeerKAT, a radio telescope array in South Africa. Dozens of dishes worked together, their signals combined electronically to create unprecedented sensitivity and resolution. Following its completion, MeerKAT began scanning the Zone of Avoidance with clarity no other instrument could match. The team tracked the 21-centimeter hydrogen signal from galaxies buried behind billions of tons of interstellar dust. Each galaxy's motion, its velocity relative to others around it, revealed the gravitational architecture invisible to light. The data came slowly, observation after observation, frame by frame. A pattern emerged gradually. The galaxies weren't scattered randomly through space. They flowed toward a common center of gravity, pulled by an immense mass that couldn't be seen directly, but could be inferred from the motion of everything surrounding it, from the way the cosmic choreography arranged itself. As the observations accumulated, the picture became unmistakable. At the center of this gravitational influence lay the Vela-Banzi Supercluster. The name comes from isiXhosa, a language spoken in South Africa, and it means revealing widely, a fitting tribute to what the telescope had finally revealed to humanity. The structure sits approximately 800 million light-years from Earth. At that distance, it belongs to the universe's ancient past. The light we're observing now left that region when the cosmos was young. The supercluster contains at least 20 galaxy clusters. A single galaxy cluster typically holds hundreds or thousands of galaxies. Each galaxy itself can contain hundreds of billions or even trillions of stars. The total inventory becomes almost incomprehensible. Uncounted trillions of stars bound together by gravity across a region of space so vast that light itself would take 20 million human lifetimes to traverse it. The scale dwarfs any single galaxy, even the largest known. It rivals other famous superclusters. The Shapley Supercluster, 600 million light-years away, held the title of the universe's largest structure for decades. Laniakea, the supercluster that contains our own Milky Way, competes in the same cosmic weight class. Yet the Vela-Banzi Supercluster remained unknown, unmapped, unseen. For millennia, it existed in darkness because our own galaxy stood in the way. The discovery prompted Kraan-Korteweg to reflect on the nearly 2 decades of work required to confirm her suspicions. It has finally confirmed the prominence of the Vela-Banzi Supercluster, something I suspected more than a decade ago, she said. The words carry weight. They remind us that some cosmic truths take years, sometimes decades, to emerge from noise and dust. But there's a deeper reason this discovery matters beyond cosmic cataloging. Astronomers have long puzzled over why galaxies in our region of space move as they do. Standard models predict certain large-scale flows. Reality diverges from the predictions. There's an anomalous pull toward a region called the Great Attractor. There are unexpected currents in the cosmic web. These discrepancies suggest that massive structures we haven't yet found were influencing everything around them. The Vela-Banzi Supercluster, now confirmed, may explain much of this mysterious cosmic motion. Its gravitational reach extends billions of light-years across space. It tugs on galaxies and entire galaxy clusters, shaping not just local motion, but the grand architecture of the universe itself. The Milky Way doesn't move randomly through the cosmos, neither does any other galaxy. All respond to the gravitational influence of nearby and distant superclusters. The Vela-Banzi Supercluster has been part of that influence for billions of years, pulling on us without our knowledge. Now that we've finally detected it, cosmologists will recalculate our galaxy's trajectory. They'll reassess their models of the universe's large-scale structure. Every mystery solved opens new questions. We know the supercluster is there. We can map its extent and estimate its mass. But we still don't fully understand why these structures cluster and collapse the way they do. We can't yet account for all the universe's cosmic architecture. The Vela-Banzi Supercluster sits at the edge of what we thought we knew, and behind it, deeper mysteries wait.